I'm Anil Kumar sharing with you a very important video on data analysis and sampling techniques. The example here is from previous test paper, so I just copied the question from the previous test paper. We are now going to analyze the given data from different angles so that we completely understand this chapter on data analysis and sampling techniques. That's the whole idea, right? So one example to work with and you'll know everything about data analysis and sampling technique. So I'd like you to have patience, go through this and understand the concepts. The question here is, a teacher surveyed his students. He asked them, on a scale of 0 to 12 hours per week inclusive, how often do you do your math homework? Their responses are shown below, right? So that's the response of the students. Now, based on this response, we have multiple questions here. First, we have based on data collection itself, that is sampling technique. Name the type of bias, if any, involved with this data. How could any potential bias be avoided? And how might teacher use this information? Perfect. Then the next question here is, what proportion of the students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per school day, right? So that's the question. And then we'll continue with many other questions which are based on making frequency tables, cumulative frequency graphs, bar graph, and then we'll also see how to group this data and work with it. Okay, so let me just answer first few and then we'll continue with the rest of the questions. Don't mind if you can't see this portion. It's okay because I'm going to repeat it. Perfect. So let's answer this first. Name the type of bias. So do we have any kind of bias? The question is, on a scale of 0 to 12 hours per week inclusive, how often do you do your homework? So a teacher is asking students in a class. So what type of bias do you think? Here it is. And why do you think so? That is very important to understand. It's an open question. Everybody can answer. So one, can you also tell me what is the population here? Okay, so let me say like this. Is it regarding population or sample? Now, yeah, that is not included here as a question, but will you consider that to be all students in this class as a population or a sample? Well, clearly it is the population since everyone in the class is involved, right? So all are expected to answer. Perfect. So it's not a sample. So that's first thing. Now let's talk about the bias. So what do you think? Is there any bias or not? You know, the students may not be frank enough. When teacher is asking a question like how many hours do you study? Those who don't really study, they won't say we don't study, right? They will say at least a couple of hours a week, right? So you are expected to get response which will result into higher, the data information will be skewed towards the higher side. So you'll get higher or better results, right? Since you are asking this kind of a question. So therefore, what we find here is that we do have a response which is not correct. And the bias here is the response bias, right? So it is called response bias. Students themselves may think that based on this answer, teacher may judge them, right? So whenever you see that there is kind of judgment or a risk of some assessment, then people may not be frank enough to respond. So that yields to a response bias. Correct? So we have answered that portion. How could any potential bias be avoided? Very easy way to avoid this is make it anonymous, right? So let them not speak out, but if they are just putting in slips without their names, right, then we can avoid the bias. Do you understand? So if you want accurate results, then it should be like on a scale of 0 to 12, don't write your names, but just write on a slip how many hours do you study per week. So that becomes a fair question, and you can expect a fair result from there. Great. The last part here is how might teacher use this information. Correct. So there are many ways teacher could use this information. One of them is, since we are talking about data analysis, teacher could see relation between hours worked to marks obtained. Right, so that could be one way. There are so many ways in which teacher could use this particular information. Correct? So we have actually answered most of the questions which are related to the sampling technique, and we understand in this particular case that we're talking to a population, all students in a class who are being addressed by this question, right? So we are not saying they are volunteering, they may or may not answer. When teacher is asking, they have to answer. So if there are like 6 times 9, 54 numbers here, which represent number of hours per week, that means we are assuming 54 students in the class. Perfect. Okay. Now, with the rest of the questions, which are, what proportion of students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per day? The data given to us is per week, so 1 hour per day means 5 hours per week, correct? So what we have to do here is that we have to figure out of these hours, how many are 5 or more, correct? So if you count that, how many are 5 or more, you can answer this question. So let's just count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So when I counted, I got 33. I'm not very sure whether this is the right number or not. So I will say, since I counted 33, it probably is more. So we'll say 33 out of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 54. Right? So it is, we'll say 33 out of 54. Correct? So if this answer is wrong, you will count yourself, correct the answer, and you can always put it in my comments. Perfect? So it could be 34, it could be 32, whatever, right? So that is the acceptable amount of homework which the students can do. Now there are a few more questions here, which is, if the teacher is saying that at least 1 hour, let me extend this, at least 1 hour per school day should be minimum, that means what? Now that means a score of 0 will treat this as an outlier. Correct? So in this example, since that 0 is not acceptable by the teacher, we are going to treat this as an outlier. Now my question to you is, with this data, can we arrange it in the group data form? Can we analyze this as a group data? That is my question to you. So that is a very important part to understand. So I'm just extending this. So would it be possible to group the data above? That's the question now, which you need to answer. Well, the question here is very clear. Can you rearrange it intervals and then figure it out? Well, some of you might think that of course we can. Let's say 0 to 3 and 4 to 6, or minus 0.5 to 3.5. Make it kind of continuous, take intervals and do it. But remember one thing, that if we have outliers, then we cannot have group data from this kind of data. So the answer is no, since we have outliers. Now, if you really want to do it, so what you can do here is you can exclude outliers. So T here, right? So you can exclude outliers and then do group analysis. Is that clear to you? So with that, we have actually covered the later half of this chapter also, where we are going to work on group data. So in the coming example, in this video, later half, we'll exclude this 0, right? We'll exclude this 0 and then rearrange the information and then represent it as a group data. Does make sense to you? So let's move on and see how to create frequency tables and draw appropriate graphs. Now let's try to analyze the data. So we'll now concentrate on data analysis. So in this example, we'll continue and make frequency table, bar graph, and frequency polygon. So I think I'll take frequency polygon in the next sheet. Now let's concentrate on frequency table and bar graph. Now before making frequency table, we need to make a T chart, right? So so we have our data here, which represents number of hours per week the students are using for their homework. So to make a chart, let me write down on the left side number of hours. So we have number of hours per week. So number of hours are from 0 to 12. So let me write down the numbers 0 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, in tally chart, what we do is we just see like 1, then we'll put one line here, 10, 10. But when the data is not that big, we could actually literally count them and straight away make a frequency table. Do you understand? So what I'll do here is I'll just count and then see how many zeros are there, how many ones are there. Correct? And I'll mark them. 0, I know there's only 1 0 here. So we'll just write number 1 for number of 0 hours. And then let's count how many ones are there. Okay. So number of ones are 1, and then 2, 3, 4. So we have 4 ones. Let me write down 4 here. Number of 2s, 1, 2, 3. Okay, so we got 3 2s. Okay, we have one more here, so let me make it 4. Found it. Okay, that's good. 4. Number of 3s, we have 1. So since we are marking them, it becomes easier. Even if we miss, we can always correct them. Correct? 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 4s. Number of 5s, 1, 2, 3, and the last one, 4. Number of 6. Number of 6 are 1, 2, 3, 4, 5, 6, 7. So it seems we have 7 6. Number of 7s. Number of 7s are So this may take time. 1, 2, 3, and 1, 4. Let me write 4 here. Number of 8s. Number of 8s are 1, 2, 3, 4, 5. 5 8s. Number of 9s. So number of 9s, 1, 2, 3, 4. Okay, and 1 here, 5. Number of 10s, 1, 2, 3, 4, 5. Number of 11s, 1 and 1, 2. Number of 12s, 1 and 1, 2. So we have taken care of all the numbers. We know there are 54 of these, right? 6 times 9 is 54. Let's count. So easy way is that we can actually make a cumulative frequency chart here. So let's say cumulative frequency. Okay, so when we count, 1 plus 4 is 5, 5 plus 4 is 9, 10, 11, 12, 20, 24, 31, 35, 40, 45, 50, 52, 54. So that is perfect. So we have 54, correct? So let's make cumulative frequency. So we are saying less than 0 or less than 0, we have 1. Adding 1 and 4, we get 5. 4 plus 4 is 8. 8 plus 4 is, 8 plus 3 is 11. 11 plus 8 is 19. We get 23 here. 30, 34, 39, 43, 44, right? And then we have 49, 49 and 2. That makes it 53. So that's not the number. We missed some number here, right? So 1, 5, 5 plus 4 is 9. Oh my God. So, okay. So let's redo. So we have 1, 5, 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 18 is 20. Then we have 24. And then 24 plus 7 is 31. 35. And this is 40. 45. 50, 52, and 54. Perfect. Finally, so we got our cumulative frequency here, right? Now let us see what type of bar graph can we make and what kind of frequency polygon can we make. Now since we have discrete data, right? Clearly we have discrete data here, so bar graph is definitely a good option. So bar graph is a good option. We have to divide into 12 equal parts to make a bar graph. So what I'll do here is construct a bar graph. So basically 12 portions. So for 0 it is 1. So we have to just represent the frequency. So at 0 it is 1. And we are going from 1 to 8. So let me also sketch some reference. That helps. So I'll just draw a few lines here. We'll say, okay, 1, 2, 3, 4, 5, 6, 7, 8 is probably the maximum. So for 0 it is 1. So this is the bar at 0. Then at 1 it is 4. It's good to write. So it is 1, 2, 3, 4. And this is 8 for us. 6 and this is 2 for us. Okay. So at 1 it is 4. So at 1 it is 4. At 2 it is again 4. So try to do it on a graph paper equally spaced. 3 it is 3. 3 it is 3. 4 it is 8. So we kind of get a maximum here. 5 it is 4. 6 it is 7. 7 it is again 4. 8 it is 5. 9 it is 5 again. 10 5 again. 11 is 2, which is here, and 12 is again 12 is 2. Perfect. So we get our bar graph. We can just label it now. So on the right side, what we have drawn is the frequency, and here this represents, let me write this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Correct? So that gives you the bar graph. Now if I have to draw the frequency diagram, then what I can do here is I can take these points here on the top and connect them with a dotted line or with a solid line. Let's just connect them, right? So I'm connecting them with a dotted line. Since it is, so this is wrong. Okay. Since it is not a continuous data, it is a discrete data, nothing in between. So that is why we are using a dotted line. Does make sense to you, right? So we have the frequency table here. We have a bar graph, and that is kind of a frequency polygon. Does make sense to you, correct? So that is how you could do all these things. So we have done, in this particular case, a frequency table, a bar graph, and a frequency polygon. Correct? Now we'll move on and then answer a few more questions. Well, there is one question which was asked last time, and that was, we can check our result, that how many will get back to the question first. So let me pick that question here. The question was kind of here. What proportion of students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per day? That means 5 hours per week. Now, since we have a cumulative frequency graph and all this, what we can now do is see what numbers are 5 or more, correct? What numbers are 5 or more, and we can actually check it out. So we can just count. So 5 or more are all these numbers. So 5 hours or more, we can add them, correct? And see our result. So acceptable amount here is 4 plus 7, 11. 11 plus 4 is 15. 20, 25, 30, and 34. So as I was expecting, our addition was wrong. So the acceptable people were, so we say 5 hours or more. So the ratio actually is 34 over 54, not 33 over 54 what we did last time. You could also do like this. Since we have this cumulative frequency now, you could take away this number from 54, correct? Which will give you 34, correct? So the number is 20, which you have to take away. So you could do 54 minus, 54. Let me change this pen. Okay. So we could do 54 minus 20, so we get 34. Do you see that? So we have this number 20 here. So we could use cumulative frequency graph also to get this number. Now let me extend this to also cumulative frequency graph, since we have the data here. So now I will do cumulative frequency. Okay, so for cumulative frequency, what do we need? So basically, we say that up to 0 hours, we have 1, and then less than 1 or less than 1 in this case, we have 5. So we could have a cumulative frequency graph also. So let me just make, the only thing is that the y scale becomes bigger since we are going up to 54. And here we have the numbers, which is hours per week. Perfect. And on this side, we have cumulative frequency. So let me sketch cumulative frequency graph also on this page. Okay. Since we are talking about 54 being the highest number, let's go by tens. So this is 10, 20, 30, 40, 50, 60. Okay, so this is for us 10, 20, 30, 40, 50 and 60. Right. So I'll just squeeze in the numbers. I'm not drawing the vertical lines. That will really make it messy. So we have the data kind of which starts from here. 0 hours. We have a student at 0 hours. So we'll start from here. 1. Now up to 1 hour. We have 5 people up to 1 hour. Okay, so this is not the data. 5 people means somewhere midway, correct? So this is 5. Then up to 2 hours is 9. So at 2, we are almost at 9. Is it okay? Then 3 is 12. So slightly more than this. This is 12.5. So it is this, 12. At 4, it is 20. So at 4, 20. 5, cumulative frequency is 24. So almost midpoint. Okay, 24. Then 31 for 6, so slightly more than 30, 31 for 6, 35 for 7, 35 is midway, okay. 40 for 8, 40 for 8, 40 is kind of here, okay. And then 45, so it's going up by 5s now, 45s. And then 50, okay, 50. And then 52, now it's kind of slowing down. And 54, right? So and 54, that's the end of it. So this represents the cumulative frequency graph. Now here we can actually, from this graph, we can see how steeply the data rises. Do you see that? So we could connect it with the line. So let me connect it with the line here. Let's connect it with the line. Correct? So all these points should be connected. We sometimes just prefer to draw straight lines between them. Now the straight lines show steepness. So that is a cumulative frequency graph, and from this graph also you could figure out many things, correct? You can find from this graph quartiles. Right? You can answer many questions like how many students work for more than 10 hours, right? Something like this. On this side, we have hours, which is 12, 0. Is it okay? And each division is 1. So like 1, 2, and so on. Perfect. 11 like this, correct? So that becomes your cumulative frequency graph. So you could also see how many students work for 5 hours or more. So what we will do here, for 5 hours or more, we can actually, we know the cumulative frequency 5 is for 1. So 5 hours or more. So number of hours 5 will be, we know this point is for 5, 24, right? So 24, probably this is for 5. Is it okay? So these are the students which are 5 or more. Do you get the idea, right? So these are the students which are 5 or more. From cumulative frequency, you can also see that the center portion is very steep, right? So let me write down this remark so that you understand how we can use cumulative frequency. So this is steep curve. And normally, maximum data here. Low. Less data, right, on this extreme. So most of the data, as you can see, is concentrated right in the center, which should normally be, and the slope therefore is maximum in the center. You can also watch some videos on how to find quartiles using cumulative frequency graph. So with that, we have analyzed all parts of understanding discrete data from this example. Now we will see how to represent this information as a group data. So the key will be eliminate the outlier and then group them. Okay.